Hey, Percy, I bet you and your car can't beat my new McLaren.
Well, guess what? My Bugatti Chiron is the fastest car in the world.
You want to bet?
Yeah, winner takes car?
Oh, okay. You just lost your Bugatti, bud. Shake on it.
Shake on it.
All right, let's go.
Before we show you who won, let's pause the video here and explain Newton's first two laws and see if you can predict the results of the race. Let's begin with Newton's first law, inertia. Newton's first law states that objects will remain at rest or at a constant velocity unless acted upon by an external force. Relating back to the race, the sports cars remained motionless until the cars applied a force to move it forwards. When the cars approached the U-turn around the train, they had a tendency to keep going in a straight line because, as stated before, objects will remain at a constant velocity unless acted upon by an external force. In order to turn, the driver must turn the wheels so that the car always applies a force to its relative left, while the friction between the wheels and the ground continue to slow it down in the undesired directions. Because the cars were moving very fast, you may also notice that the rear of the car swing out due to their tendency to remain at a constant velocity, while the front wheel attempts to turn the car by applying a force to the left of the car. Next, let's talk about Newton's second law of motion. In the 18th century, physicists discovered the relation between force, mass, and acceleration. This would become known as Newton's second law. Net force is equal to mass times acceleration. But how does this equation explain why the lighter McLaren and the more powerful Bugatti accelerated at the same rate? This is because even though the Bugatti has a much more powerful engine, the McLaren, due to its lower weight, requires less force to achieve the same acceleration. For example, if the Bugatti's engine delivers a theoretical 10,000 newtons of force and has a weight of 1,000 kilograms, while the McLaren delivers a theoretical 8,000 newtons of force and has a weight of 800 kilograms, using Newton's second law, F equals ma can be rearranged into F divided by m equals a, and by doing the math, 10,000 divided by 1,000 is the same thing as 8,000 divided by 800, so both cars accelerate at the same rate. Now that you've learned about Newton's first and second laws, let's see what happens next.
Newton's third law states that for every acting force, there is an immediate reaction of equal force in the opposite direction. What does this mean exactly? Take the example of when I used my rocket boost to speed ahead of Percy, which is totally legal and fair by all standards. My rocket boost used rocket propellant, which underwent a chemical reaction that shot gas out of the exhaust, propelling my car forwards to win the race. When the exhaust in my car expelled the gas out, the gas was released at a high speed and in a large volume, which in turn pushed back against the car, propelling it forwards.
When Percy rammed Lucy at the end of the race, all three of Newton's laws are demonstrated. The first law was the reason why Lucy got hit, as Percy was trying so hard to catch up to me in his Bugatti that he did not account for the finish line. Since the mass of the Bugatti was so large, the inertia prevented him from stopping on time. But why didn't the car get pushed backwards? The answer is it kinda did, but not really. This is because there is a massive difference between the mass of the car and the mass of Lucy. By arranging the equation F equals ma into F over m equals a, we know that the same amount of force is applied to both objects, the Bugatti and Lucy. But since the mass of the Bugatti is much greater, the acceleration of the Bugatti will be much smaller compared to the acceleration of Lucy. The third law, though not apparent, was evident if enough data was collected. When the Bugatti rammed Lucy, she also slowed the Bugatti due to the opposite reaction force she exerted. Though it did not do much, it would definitely have been noticeable if, say, a brick wall was placed behind her.